Good afternoon. Okay, we're going to learn today about factoring by grouping. So this is not something that was covered in your Khan Academy video, so I think this will help to kind of reinforce what's going to be said in this week's lesson. So hopefully this is a starting place for you. So those of you that don't know me, I am Miss Smith, and let's get started. So I'm going to share my screen with you guys, and we're going to work on factoring by grouping. Okay. All right, so here we are. So we are factoring by grouping today. All right, so first things first, let's review a little bit. Okay, so we're gonna factor out our GCF. So these terms have a greatest common factor. For those of you that don't remember what GCF means, it is greatest common factor. So we're gonna find that greatest common factor between each of the terms. And the terms are the pieces of an expression separated by addition or subtraction. So we're gonna find the GCF of all of those. So first we're going to look at the coefficient, the number in front. So 9, 15, and 3. So those have a GCF, okay, 9, 15, and 3, and their greatest common factor would be 3. So 3 goes into 9 3 times, it goes into 15 5 times, and it goes into 3 once. So that's why that's the GCF. So we have a GCF of 3. But then all the terms also share an A. So we can take out the smallest number of A's that we have, and we see there's 4 of them here, 3 of them here, and 2 of them here. So we can take out 2 A's, A squared. And then all 3 terms also have a B, so we can take out the smallest number of B's that we have. And so there's 3 here, 2 here, and then there's that invisible one. So we talked about how like mathematicians don't like ones, and so they don't put ones. So when there's just a variable by itself, that's like it's raised to the 1 power. So we can take out one of our b's. So our greatest common factor of this polynomial is 3a squared b. Then we open up a parenthesis, and we're going to see what's left on the inside. Okay, so 3 times what? So it's kind of like I'm backwards distributing. Okay, so I want to decide 3 times what gives me 9? Well, 3 times 3. Then there were 4 A's here, but I only factored out 2, so that means I need 2 more on the inside of this parentheses. Because we add, when we multiply variables with exponents, we add their exponents together. Okay, so then we only took out 1 B, but there's 3 of them here, so that means we need 2 more. So then we're going to have 2 B's left inside for that first term. Then I'm going to do the next distributing. Okay, so let's get rid of those. All right, so 3 times what gives me positive 15? Well, positive 5. Then I factored out 2 A's, and there's 3 A's in this original problem. And so that means I need 1 more, so it's going to be 5A. Then I only factored out 1 B, but there were 2 in our original problem. So that means we need 1 more B. Okay? And that's it for that term. Then the last term, 3 times what would give me negative 3? Well, it's a negative 1. Or in math, we don't have to write the 1. If you like the 1, you can write it, but I'm just going to write negative sign for a second, and then we can look. Do we need any more variables? So if we were to multiply that so 3 times negative 1 gives us the negative 3, but then I already factored out a squared. Well, there's a squared there. Good. Okay, so then I factored out 1b. Well, there's only 1b, so I'm good, which is the goal. You want that last term to be a constant. And since there weren't any variables, we did have to end up putting that 1 there. But just for good measure to remember, we don't have to. So that was in other problems when there's a variable. So that is your review. So that is factoring out a GCF. Okay, so with factoring with grouping, we're going to see that we still have to use these GCF skills, but this time our GCF is going to be a binomial. So let's look at this problem. Let's factor out the GCF in this problem. So this time our GCF is a binomial, which we learned before spring break that means that there are 2 terms. So this time our GCF is x minus 2. both of those terms share an x minus 2. So we can factor that out one time. So we rewrite that common term, x minus 2 in parentheses. And then we're going to take those other pieces that are left, 6 plus y, and put them in parentheses, and they make their own term. And that's it. That's your answer. So you take the ones that the binomial, the common binomial, rewrite it one time, take the two outside pieces, make them into their own binomial, and that's it. Okay, so that's our key reminders for factoring by grouping. Okay, so here are our rules for factoring by grouping. So we factor by grouping when we have 4 or more terms. So when we have even numbers of terms, 4 or more, then we can look for a common binomial factor. Okay, so let's kind of work through this example. So this says, so we're not going to look for a GCF of all 4 terms, or we're going to look for it, but we're going to notice that there's not one in this problem. Okay, so there's 2, 8, 3, and 12. Those don't have a greatest common factor, just a number. I can't take that out. So instead, this time we're going to factor by grouping. So we're going to put the first 2 together. That's where these parentheses came from. Okay, so we're going to factor where we're going to group the first 2 terms and the last 2 terms together. Then we're going to use our unmultiplying rules. We're going to factor out the GCF of each of those groups. Okay, so we're going to factor from each of the groups. So in this group, from the first one, we saw a GCF of 2. That's where that 2 came from. And we could have factored out a whole x squared. Okay, because the smallest number of x's that it shared was 2. So we factored out an x squared, and then we were seeing what was left on the inside. Okay, so what's left on the inside, if we were to multiply this back in, would be 2 times that invisible 1 would give me 2, and then x squared times x would give me x cubed. Okay, then 2 times 4 would give me 8, and then I already factored out an x squared, so that's all that is left there. Okay, so that's the first term, or the first group. Then we're going to do the same thing with the second group. So we're dropping that plus down, then we see 3 and 12. Well, they have a GCF of 3. This piece right here didn't have an x, so I can't take out an x. I'm only going to take out a 3. Okay, and so then we're going to unmultiply, or we're going to reverse distributive property and see if we can figure out what would be left on the inside. So 3 times what would give me 3x? 3 times what would give me 3x? 3x. X. And then 3 times what would give me, let's see, let's erase that. Okay, 3 times 4, or would give me 12, and that's where they got the 4. So then we're going to take we're going to factor out that common binomial now, like we did in the last one. We're going to see that there's a common binomial. It shares an x4. So we're going to rewrite that one time, in parentheses, one time. And then we're going to take those other pieces, 2x squared plus 3, and make their own factor. And then you could always double distribute or FOIL or shirts and pants to check your answer. Okay, so let's see this in action. Okay, so the first step, group the first 2 terms and the last 2 terms. Okay, then we're going to find the GCF of the first group, the greatest common factor of the first group, CD plus 3C. They both share a C. Okay, so we're going to factor out a C. And then I'm going to see what's left on the inside. So C times what would give me CD? Well, D. Then C times what would give me 3C plus 3. So it's whatever would be left on the inside if I were to undistribute that. Okay, so that's the first one. Drop down that minus. Let's see, what is 3? What's the GCF of 3 and 9? Well, it's 3. So we can factor out a 3. And because that 9 doesn't have a D, I can't take a D out. So I'm ready to see what's left. So negative 3 times what would give me that 3D? Well, I'm missing a D. And then we got to watch that sign. So this is a negative 3 times what would give me a negative 9? Well, it's going to be a positive 3. And the goal we should know that it should be a positive 3 because the goal is that it looks just like the factor that we found over here. Because now we have a common binomial. And so now that we have a common binomial, we bring that down one time. So we're going to rewrite it d plus 3. We're going to rewrite it one time. And then we're going to take those other pieces, c minus 3, and they're going to make their own term or their own factor, c minus 3. And that's your answer. That's factoring by grouping. Group the first two, the last two, take out the GCF of each group, then bring down the common binomial one time, take the other two pieces, move them over into their own factor. That's it. All right, so the next problem, okay, let's factor by grouping. So the first step is that we are going to group the first two terms and the last two terms. Okay, so the first two terms and then the last two terms. So we're just gonna put parentheses around them, group them together. Okay, so then we need to find the GCF of the first two terms. So 14 and 21. So we're first gonna look at those coefficients, 14 and 21. So the GCF of 14 and 21 would be 7. Then we notice that they both have z's. So we can take out the smallest number of z's that we have, which is 2. So we're going to take out a z squared. Okay, then we're going to see what's left on the inside. So 7 times what would give me 14? 2. Then I factored out 2 z's, but there's 3 in my original problem. So that means I need 1 more inside my parentheses. Okay, then 7 times what? So we're distributing again. 7 times what would give me positive 21? Well, it'd be 7 times 3, positive 3. And I already factored out 2 z's, and there's 2 z's in the problem, so I'm done. And that's your goal, is that you don't have any left in that binomial. Yes, occasionally there will be, but rarely. Okay, so especially not really that much in Algebra 1. All right, so moving on to the second group. So again, the first step is to find the GCF. So I'm gonna drop that minus in the GCF of 6 and 9. The GCF of 6 and 9, hopefully you know it, it's 3. Okay, then we're gonna see what's left inside. Well, 3 times what would give me that 6? Well, 2. And there was a z on the inside of the parentheses. So I'm gonna leave a z on the inside on the bottom when we drop it down. Okay, so then negative 3 times what would give me negative 9? We have to watch those signs again. So negative 3 times positive 3 would give me negative 9, which is perfect. That's exactly what we wanted it to be because we want to see that there's a common binomial. So we should see a common binomial when we're done factoring by grouping. Okay, and so we see that common binomial, so we're going to drop that down one time. One time. So we have 2z plus 3 is my first factor. And then my second factor is going to be the first GCF and the second GCF put together in another factor. So we just drop those down together. 7, it's kind of that 7 z squared minus 3. Just like that, and that's your answer. All right, let's try another. Okay, again, first two terms, second two terms. Or last two terms would probably be the better way to say that. So first two, last two, group them together, find their GCF. So the GCF of 6 and 4, so start with those coefficients of 6 and 4 is 2. They both share an x, and so we can take out the smallest number of x's, and if we remember, then an x by itself is like an x to the 1, so we can take out 1x. And then we're going to open up parentheses and see what would be left on the inside. So that's our GCF. So then 2 times what gives me 6? 3. Then I factored out 1x, but there's 3 in the original problem, so that means I need to leave 2 inside the parentheses. X squared. Okay, then 2x times what would give me 4x? Well, 2 times 2 gives me 4, positive 2. And I already factored out 1x, and there's only 1x in the original terms or original problem, so we are done. Okay, now we need to find the GCF of 9 and 6. 9 and 6, we actually just did this one, so hopefully remember that it's 3. Okay, then 3 times what gives me 9? 3. There's an x squared in the top or in our problem, and we only factored out a 3, so that means we need to leave that x squared inside our parenthesis. And then negative 3 times what gives me negative 6? Positive 2. And that's perfect. That's exactly what we wanted it to be, because now we can see we have a common binomial. A common binomial. So we're going to drop down that common binomial one time. 3x squared plus 2 times, take those other two pieces, 2x minus 3, put it in a factor, and that is your factored form. And again, you could shirts and pants, foil, double distribute, however you want to word that to be able to check your answer. And I think that's it for us, guys. So this is the first lesson. There will be one to follow. So just to kind of give you guys an overview of the things that are going to be going on this week. So make sure that you also watch the next video, and then Khan Academy videos will kind of just help to reinforce those skills and to see more examples. We miss you guys. It's an Algebra 1 team. We miss you guys. We'd much rather be doing this in person, but we're going to make this work. And I'll see you in the next video.